Hello, guys. Yan. We're back na lahat, I guess. Yan. So, are we good? Are we good to start or you need more time? 5 minutes to, paano na to breathe and to, to get your, it's the ungodly hour na later. So, start na. O, sige po, palaban. Laban na laban tayo. Sige, let's start na po. Busog na. Sana all. Sana all busog. Char. Sige. Sige, let's start. May I have Miss Nova, Miss Princess, and Miss Lucky Faye to share reacts, kahit heart if we're ready. Or if you're there na behind the screen, kung ready na tayo. Can I see kung ready na? Makakita ng ano ba to? Yan. Can I see kung okay na tayo mag-start? Press lang ng heart reaction. Ayan pala. Okay, dito ko pala makikita yung reactions. Nag-react ba? Ay, okay na. Sige. Ayaw mag-heart ni Miss Princess. Sige, so let's start this lecture, second part tayo. So welcome to the second half of this session. No? So I hope you somehow absorb what we had tackled this morning. So medyo balik lang tayo nun sa sa basic concepts of general chemistry kanina, no? So you have remembered siguro ang pinakatumatak sa inyo yung Lewis structure and then geometry and then polarities, no? Yun yung parang main concept nung recap nung kaninang morning, no? The flower, okay? Now, this session naman, yung session 2, so we'll focus more now on organic molecules particularly that will be somehow related to the first lecture that we had kanina. No? So without the concepts a while ago, baka hindi natin mag-grasp what's happening here in the structure of organic compounds. Okay? So this afternoon, we're going to introduce organic chemistry and then relate it to other branches of chem. So, but this is just a short part lang. And then nomenclature, kasi kaya ko to in-emphasize. I think this is one of the longest lecture for this afternoon kasi I made this lecture na parang lahat ng functional group covered at least para hindi kayo magulat sa exam na bakit lahat na ng functional group nandyan na sa molecule. So parang ganon. Okay? Kaya I made it to a point na all of the functional groups are shown or will be shown in this lecture. Pero due to the limited time that we have, so 4 hours lang 4 hours lang tayo, then you will have an assessment after. We will just choose items that we need to answer or we will answer. And then the rest of those you will not be answering or we will not be answering together. Self-review nyo na lang siya. Then if you want to, for me to at least coach you during answering, you may naman. Okay? Kasi kailangan din nating targetin is the isomerism kasi this really has importance in organic compounds, particularly those molecules na medyo parehas ng molecular formula but different structure, no? And then properties of organic compounds, ito yung medyo may mga trends later on sa exam. So baka may mga ganun lumabas like trends in boiling point, melting point, and solubility. No, kaya we will focus this afternoon on this one. And then again, in the following session, hinati ko na lang yung sessions into 2 for organic chemistry since majority tatlo lang kayo, no? Parang meron sa inyo na nahihirapan sa organic reactions. So next topic yon, parang we will focus on that. No? And then hopefully in the afternoon next session, mag-start na tayo sa GLPs and waste segregation, no? Although yan, medyo papahapyawan lang natin yung yung important parts, no, ng GLP and waste management next session. Pero I hope that matapos tayo on time na next session. Okay? Yan. So let's start. So to introduce organic chemistry, so I think you're already well acquainted with organic chemistry. That organic chemistry is the study of the properties of carbon-containing compounds, no? So maraming gamit si organic chemistry, no? As you all know. So usually this evolves to being solvent systems, yan, like mga polymers, no, from anilines to pyridines to thiophene. So ito yung mga starting material for polymeric compounds, no, yung mga plastics natin, yung mga lalagyanan ng kung ano-ano, no, particularly plastics kasi polymer-based resins yung mga yan eh. Then phenols, your solvents, menthol, flavoring, so yung mga essential oils natin na nilalagay pag stress na tayo, ganyan. Dito galing sa organic compounds, no? Yung mga menthol, eucalyptic compounds natin, fragrances of perfumes, no? Yung flavors, no? Carbon molecules lahat 'yan. All right? Now, what do we study in organic chemistry is all about carbon-containing compounds. Primarily, its structure, properties, compositions, reactions, and preparations. So, to which we will be starting to study at this for today, no? Until the following session. Okay? Now, why is carbon special? Okay, sana all special, ganun. Okay, so why is carbon special? Because it is tetravalent. So, ibig sabihin parang among the among the elements found in the periodic table, ito lang yung may kumbaga sa octet, 'di ba? Sa octet 8. So, 4 doon magbaband, and then yung 4, parang wala lang. So, siya, parang tetravalent kasi 4 sa octet nagbaband, tapos yung 4, it may be gone somewhere or kasama siya dun sa bonding mismo. Okay? So, yan. So, kaya siya special because it is tetravalent, meaning it can form 4 bonds together. So, pwede siyang maging multiple bonds, like double bonds in alkene structures, or pwede siyang maging triple bonds in alkynes, such as this ethene molecule and in ethine. Okay, so ito yung mga common bonds that can be formed. Sabi ko nga kanina, sa covalent bonds, which is the predominant bonds in carbon containing molecules, yan, pwede kang magkaroon ng double bond or triple bond. Okay? Now, sabi ko kanina din as to in the introduction of general chemistry concepts, when carbon is formed, when carbon bonds are formed, polar covalent bonds ay nangyayari unless yun nga same carbon molecule yung naka-form, okay? Or like this one, yung CCl bond, nagkakaroon siya ng polar covalent due to its dipole moment. Okay? Kasi yung chlorine ay more electronegative. That's why here in the molecular model here, mas nagiging electron dense si chlorine. Kasi nga, hinihigop ni chlorine yung electrons ni carbon. Okay, therefore, mas nagiging electron dense si chlorine. Kaya nagkakaroon ng polar covalent bonds. Okay? Now, for organic molecules, it's important to note that aside from what we have introduced earlier na bonds, so ano yung dalawang bond kanina nating nabanggit? Teka lang. Yan. Meron tayong covalent bonds at saka ionic, di ba? And I've emphasized that this is intramolecular, meaning intra is within the molecule. So ito yung 2 bonds that exists within the molecules, no? Organic compounds can also form bonds across other molecules. And this is quite evident, especially for organic molecules that are being complex or being bonded to other molecules. Kasi uso yan sa organic eh. Maraming binding sites ang mga organic molecules, which hindi natin masyadong i-detail kasi mababaw lang tayo for Chemtech. Pero yung organic molecules ay maraming pwedeng binding sites kasi nga due to the deficiency of electrons of carbon, 'di ba? So kapag electron deficit si carbon, kasi hinihigop nga ng electronegative atom, tendencies, nagiging, parang nagkakaroon ng binding site si carbon kasi nga kulang siya sa electron. So what happens? Nagkakaroon ng intermolecular forces of attraction. So IMFA here means intermolecular forces of attraction. Okay? So yan ang ibig sabihin ng IMFA. So when you say IMFA, yung shortcut niyan, ibig sabihin reactions or interactions or binding of molecules between other molecules din na organic. Okay? Actually, pwede ring inorganic molecules ang i-bond. Pero since we are focused only on organic lang tayo. Okay? So, pwedeng magkaroon ng tatlo. So, itong tatlong to, pwede siyang mag-occur. Okay? For organic. Since ion-ion interactions normally don't happen in organic compounds. Okay? Pero it's important to note also this type of interaction. Okay? For ion-ion interactions, these are quite happening for inorganic compounds. Okay? Kasi nga ions eh. Okay? Sa organic chemistry, walang masyadong ions. Okay? Unless the carbon molecules will form ionic compounds, pero that's rare. Okay? Usually sa ion-ion interactions, inorganic entities ito, no? So these are attractive force between ions with opposite charges. So for example, si NH4+ at saka si NO3-. So si ammonium at si nitrate, pwede siyang magkaroon ng ion-ion interactions. Although these are ions, they are molecules to start with. Okay? So kaya ang kanyang principle is ion-ion interaction. Okay? Yan. Mostly this is for inorganic entities. Ngayon, sa organic chemistry, what really is predominant are the three. So van der Waals. So this is read as van der Waals daw, hindi siya van, from German daw or something yung pinanggalingan, originated nitong term. So van der Waals forces, dipole-dipole interactions, and hydrogen bonding. Okay? Now, van der Waals or the London dispersion forces, yun yung pangalan niya. So these are very weak interactions caused by a momentarily change in electron density, and this is the predominant force in nonpolar compounds. So ano ulit yung nonpolar compounds? Guys, babalik tayo sa polar, nonpolar, no? So nonpolar compounds, again, ay yung merong maliit na difference or walang totally difference sa electronegativity. Okay? Or yung pag sinabi mong nonpolar, yung same elements ang nakakabit, most likely nonpolar siya. Okay? So kapag nonpolar ang molecule mo, meron kang agad van der Waals forces or London dispersion. And this is categorized as very weak. So ibig sabihin, madali siyang ma-break, madali siyang mag-cleave, later on, madali siyang masira, yung buong molecule. Okay? Kasi nga, very weak interaction siya. Okay? So, kuha yun. So, van der Waals is the weakest actually of all interactions listed here. Yan. Siya yung pinakamahina. Okay? Next, now, dipole-dipole interactions are attractive forces between the permanent dipoles of two polar molecules. Okay? So, ito naman ay nag-e-exist siya sa molecules with a net dipole. Okay? Meron siyang dipole moment. Or, these are attractive forces with polar covalent molecules. No? So, yung may mga polar covalent bonds. Yan, dito papasok si dipole-dipole interaction. Okay? So, again ulitin natin para clear. Si ion-ion interaction, ions yan. So, ionic compounds or ionic entities ang nagbabond. Okay? Usually, pag polar yung compound, hindi ito kasama. Wala totally. Okay? Wala totally. Kundi ions lang ang nagbabond here. Okay? Pag van der Waals, non-polar. Okay? Bonds ang nandito. And when you have non-polar molecules, ang nag-e-exist na IMFA sa kanya ay van der Waals. Pag polar covalent molecules, pwedeng dipole-dipole interaction. Okay? Ang nag-o-occur. Pwede rin actually hydrogen bonding kasi ano siya halogenic yung mga electronegative atoms yung nagbabond dito. Okay? Pero usually, pag polar interactions, dipole-dipole agad siya. Okay? And then, pag hydrogen bonding, it occurs when a hydrogen atom is bonded to either oxygen, nitrogen, or fluorine. Okay? When a hydrogen atom bonded to any of these atoms, oxygen, nitrogen, and fluorine, is electrostatically attracted to a lone pair of electrons on oxygen, nitrogen, or fluorine in another molecule. Okay? So yan. And this is the strongest of the 3 types of intermolecular forces. Parang mali yung nabigay kong example here. Pero sige yon. Basta ang term dito is IMFA, no? Intermolecular, meaning kumbaga interaction siya sa ibang molecule. No, I think this one was hindi ito yung example kasi this is inter, no? Kasi nga ano siya, same within the molecule. Okay? So basta guys, ganun na, ion-ion interactions in organic compounds are concerned. Van der Waals or London dispersion forces, non-polar entities or non-polar molecules bonded together. Dipole-dipole interactions, polar covalent usually. Okay? So pag magbaband si polar covalent molecules, dipole-dipole interaction siya. And hydrogen bonding occurs when a hydrogen atom bonded to these 3, so oxygen, nitrogen, or fluorine, is bonded to a lone pair of electrons of oxygen, nitrogen, fluorine. Okay, and this is typically the strongest among all IMFA present. Okay. Now, IMFA is important because it is responsible for the bulk properties of matter. Example, yung boiling point, melting points, and the solubility. Kasi the degree of those properties will depend on how easy or how hard it is to break bonds. No? Kaya yun yung relevance niya. No? When it is weak, mas madali siyang ma-break. Therefore, mas madali siyang mag-boil. Siyempre, kasi when you induce heat in a bond, magkakaroon ka ng breakage of bonds or destroying of bonds, cleavage of bonds, depende sa reaction. Kaya, pag weaker, mas mabilis siyang mag-boil, di ba? Ganun yung essence. Pag stronger, mas mabilis or mas matagal siyang mag-boil. Parang ganun. So, kapag may van der Waals kang bonds, which is non-polar, ibig sabihin, weaker yung bonds mo. Okay? Pero pag yung mga polar, mas mahirap siyang i-boil, for example. Or, ano pa bang pwedeng characteristic? Yung solubility later on. So, yung solubility, since hydrogen bonding is parang more persistent with water molecules, kasi yung water mo H2O, diba? So, si H2O, merong lone pair yan na dalawa. Okay? So, itong dalawang to, ito yung magbaband sa ibang organic compounds, lalo na sa pag tinetest mo yung solubility. Kaya, pag mas maraming H-bonding point sites yung iyong molecule, mas soluble siya sa tubig. Ganon. So, ganon yung which we will be tackling later sa properties. Okay? Kaya ako to in-introduce is because it relates to it, no? Sa mga susunod na concept natin. Okay? So, this table shows us that the type of force, the relative strengths of each, and what molecules exhibit those. Okay? So actually, ang van der Waals, lahat ng molecules meron, pero hindi lahat ng molecules ay predominant siya. Okay? For example, si dipole-dipole, tingnan nyo. Etong CH3, CH2, ano to? 1, 2, 3, 4. So this is butanaldehyde, no? So 1, 2, 3, 4. So ano siya? 1, 2, 3, 4. Ganyan siya. CHO, yan. Okay, so 1, 2, 3, 4. Ito siya. Okay? So, nakikita nyo sa table, dalawang bonds ang meron siya or dalawang infa. So, van der Waals at saka dipole. Okay? Bakit kaya? Ba't kaya may van der Waals din siya? Kasi ang van der Waals nakikita sa carbon to carbon bonding. 'Di ba? Yan, tingnan nyo, yung carbon to carbon din ito at saka ito. Yung bond nito may van der Waals. Yung carbon to carbon na to may van der Waals. Okay? Pero, alin dyan ang dipole-dipole? Ito, carbon to oxygen. So, yan yung may dipole-dipole. Okay? Kaya, ang nakalagay dito, all molecules. Pero, ang predominant at ang stronger force ay ang dipole-dipole. Okay? Hindi lahat ng bonds or hindi lahat ng bonds ay i-consider mo sa polarity later on. Okay? Kundi what's the most predominant? Okay? Yan. So for example, ito hydrogen bonding. Usually, ang hydrogen bonds are seen on alcohols. Lahat ng may oxygen, nitrogen, fluorine. Okay? Pag may nitrogen, oxygen, at fluorine na yan, matik na yan na hydrogen bond. Okay? And then ion, ito ionic to, 'di ba? NaCl. Lithium fluoride is also ionic. So, yun lang ang mag-e-exist sa kanya. Okay? So again when you say most predominant, yun yung ang pipiliin nyo doon is yung mas strong. Okay? Which is, for example, si butanaldehyde, ang much stronger or more predominant is the dipole-dipole. Okay? Great. Now, sige, let's try to answer this. So, what is the most predominant INFA present in each of the molecules presented? Okay? So, let's try pentanal. What's the most predominant kaya? Okay? What's the most, here? Predominant? Sa aldehyde or sa pentanal nito na aldehyde structure? What could be the most evident or the most predominant INFA in pentanal? Ano kaya? Nawala si Nova. Nawala siya ha. Ayun, anyway. Sige, Miss Lucky Fee, ano kayang predominant INFA nito? Okay, so, parang wala siya. Miss Princess, ano kayang most predominant bond? Wala. Sige, nag-unmute sila eh. Gising naman yung mga yan, nag-iisip lang, Sir Chris. Nag-iisip lang sila. Sige, game. What's the most predominant? Sige. Doon po sa may hydrogen and oxygen. Hydrogen, may nakaband ba sa oxygen? What you mean is, yung entity na merong oxygen bonded to carbon, tapos nakaband sa hydrogen. Okay, so what's that Ha? What's the most predominant INFA na lang? That's the question eh. Yan. What's the most predominant? Is it yung 4? Yan. What's the most predominant? Is it ion-ion?
Dipole-dipole interaction mo.
Dipole-dipole. Very good. So, dipole-dipole siya. Okay? Hindi siya hydrogen bond kasi dito, wala nang lone pair si oxygen. Ay, sorry. Well, dito, wala nang lone pair si oxygen. Okay? Kaya hindi siya magkakaroon ng hydrogen bond. Okay? Pero pag dipole-dipole, si carbon at si oxygen mo, merong dipole moment. Okay? Kaya, yun yung predominant niya na infra. Okay? Pero again, sabi ko kanina, yung carbon to carbon bonds dyan may van der Waals. So, carbon to carbon, van der Waals, carbon to carbon, van der Waals din. Okay? Next, si hexane. Ano kayang most predominant? Most predominant bond dyan. Ano kayang most